In section 4.4, we talk about the geometric distribution. There are some conditions for the geometric distribution. There must be one or more binomial trials. These are also called Bernoulli trials. The Bernoulli trials are defined down here. Bernoulli trials in an experiment have the following characteristics. There are only two possible outcomes. Remember, these will be called success or failure for each trial. We call the probability of success P, and it must stay the same for any trial. And the probability of failure we call Q. It is calculated as 1 minus the probability of success, and it is also the same for any trial. So what will make the geometric distribution is that we'll have one or more of these binomial or Bernoulli trials, and there will be all failures until the last one. The random variable x will be defined as the number of independent trials to get the first success, and it will include that success. So x can take on values 1, 2, 3, up to infinity. So this is a discrete distribution, okay? The random variable can only take on discrete values. So when we say x is equal to 4, that means there were 4 trials, and there was a failure, a failure, a failure on the first 3, and then finally we get the success. And then, excuse me, and then just to reiterate, all of these trials are identical and they are independent, and the probability of success is the same for all trials. Okay, so the geometric distribution, binomial, failure, 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 success. Okay. So the way we notate this geometric distribution is we will say that x follows g of p, where p is the probability of success. We can see that the probability that x takes on any given value will be 1 minus p, that's the probability of failure, for every attempt except for the last one, and then we multiply by the probability of success. The mean of the distribution, mu, is the expected value. We calculate that as 1 over p. The variance takes 1 over p, and then takes 1 over p minus 1, and we multiply those together. And as always, the standard deviation is the square root of the variance. Now we can also calculate this on our calculator. So you'll have to access the distribution menu, that's through second and the vars key. And when you scroll down, you'll see the probability that x is equal to x is the Geomet PDF. Okay, this is the non-cumulative version. And if you want the cumulative version where x is less than or equal to a given value, you will use the CDF.